5/8 is called applying special right triangles. So there are two special right triangles. One of them is a 45 degree, 90 degree. That's the first special right triangle. And the second one is the 30 degree, 60 degree, 90 degree. These add up to 180. These add up to 180. But I'm sure you can see that just by looking at them, why they're considered special, right? This one has two 45s, and this one has 30, 60, 90. So it's multiples of 30, okay, or multiples of 3, okay? So in your notes, you're going to take your note card and you're going to trace it, because later you're going to come back and staple your note card in there, or tape it in there, or glue it in there if you have a fancy glue stick.
Yeah.
I do on the back end.
Which way?
I would say horizontally, left to right. Yeah. Okay, so on one side, you're going to title it Special Right Triangles. And when you tape it in there, that's the side that'll go down, because that's really just repeat of the title up there. And then on the other side, we're going to fold it in half. And we're going to draw the two special right triangles. So on the left, we'll do the 45, 45, 90. And then on the right, we'll do the 30, 60, 90. Okay? So on the 45, 45, 90 triangle, we only have to draw one of them. Okay, so you're going to draw a right triangle, and the two sides that are the legs are going to have the same measurement, and they're going to have the same ratio of 1 to 1. If this angle is 45 degrees and this angle is 45 degrees, then the two sides opposite them are each going to have a ratio of 1. Okay? So if this one was 9 inches, this one would also be 9 inches. Okay? So whatever one is, the other leg is the same measurement. Okay? The only one that's different is the side that's opposite the 90 degree. That's called the what? Who knows the name, special name of that side? Hypotenuse, right? That hypotenuse is going to have a ratio of the square root of 2. Right? So on your assignment, when you see a triangle and it has 45 listed as both of its two other angles, or even just one, you can assume that the third one will be 45 as well. Then you can take this triangle and you can turn it using your index card until it matches whatever direction that one's facing. Okay, so we'll see that in just a second. Okay, for the 30, 60, 90 triangle, we need to draw 2. Why? Because sometimes the triangle is drawn facing one direction and sometimes it's drawn facing another direction. Okay, so it's easier to match it up if you have 2. You just decide, is it more like this one or is it more like this one, and then you turn it until it matches perfectly. Okay, so we're going to go 30, 60, and then obviously there's your 90. Or the one facing this way is basically just the opposite, 30, 60, and then there's your 90. Okay? So opposite the 60 degrees and opposite the 60 degrees. In the middle here, we're going to have a ratio of square root of 3. And that'll be this side or this side. And then opposite the 30 degrees, you'll have a ratio of 1. Opposite the 30, ratio of 1. And that leaves your hypotenuse on both to be 2 and 2. Okay. If you want to write the rad 3 twice, you can. Okay? So here's how it's going to work. You're going to be given a triangle, and that triangle is going to be a 45, 45, 90, or it's going to be a 30, 60, 90. Okay? What I do is I fold it under, and I keep the one that it is facing up. So if it's the 45, 45, 90, I leave this facing up, so I don't get them confused. Okay? And then you're going to take it and you're going to set up a proportion using the ratios from here and the ratios given to you in the problem. And then just like with any other proportion you're given in math, you do the cross product and you solve for the missing side. Okay? So example number 1. Yes. All right. So example number 1. You know it's a right triangle because it's got the little box, right? And then they gave you one of the angles. It's 45, so what's the other? 45. If it helps you, write it in. If you're just super smart, you just know. Okay? So I'm going to fold that side under, and I'm going to have the 45, 45, 90 showing. But if I just keep it turned this way, it doesn't necessarily match up. So I'm going to turn it so that it matches up nicely, right? I can see that the side that's labeled 8 inches matches up to the side that's 1 inch. So that's going to be my first fraction. So I'm going to say 8 to 1. Okay? This side matches this side, so this one's 8, this one's 1. Then I'm going to write my equal sign. And then I can see that the hypotenuse matches the hypotenuse over here. So I'm going to, because I did this triangle first in the numerator, I have to do that triangle first in the numerator as well. So that's where the x goes. And then in the denominator is this side, which is the square root of 2. This is called a proportion. Okay. Once you have a proportion, you do your cross product. I prefer my variable on the left, so I can see that if I go this direction, I have 1 times x. That's going to be equal to this cross, which is 8 times the square root of 2, and I do the cross product, meaning multiply, right? Okay, so 1 times x is just x. 8 rad 2, under that radical, you can't simplify it. If it just says to give your answer as a simplified radical, leave it like that. If it asks you to change it to a decimal, then just type it in your calculator and do the wavy equal sign. Okay? So simplify the radical if possible. If you have any perfect square factors under there, pull them out. This one was not possible. Okay? Let's look at another one. So on this one, we had the hypotenuse missing, right? In example number 2, we're going to draw our triangle facing down like that. That makes our right angle right there. We have x, and we have 5 meters. Oh, and this is a 45, Now, even if they don't give you this measurement of 45 degrees here and 45 degrees here, like if it was blank here and here, these two angles, you could tell that it was a 45 by 45 because these two are the same, right? They have the same measurement, or they both have the same variable x. That makes these two angles the same versus being the 30 and the 60, okay? So we need again, the 45, 45, 90. So we're going to turn it so that it's upside down, right? I'm going to put it up here, kind of, Okay? All right, so the leg of x should match the leg of 1. So we're going to write x over 1. So I did the leg in the problem to the leg, bless you, in the ratio. Set that equal to the hypotenuse in the problem, which is 5, to the hypotenuse in the ratio, which is the square root of 2. Okay. So if you do it the same way every time, if you do the problem to the card every time, then you won't get confused. Okay? So in the numerator, always write what's in the problem. In the denominator, always write the ratio that's on your card. But if you prefer it the other way, then that would work too. Okay? Once you have your proportion, you're going to do your cross product. So here's the x. So I'm going to go this direction. So I'm going to have x times the square root of 2. Set that equal to 1 times 5. And then I need to simplify. So x times the square root of 2 is really just the square root of 2 times x. 1 times 5 is just 5. And then here's where you're going to see a pre-algebra thing. And hopefully you remember how to do this. But if x is being multiplied by the square root of 2, to get it by itself, you need to divide by the square root of 2. So on the left, they cancel. Awesome. Good. But on the right, we have 5 over the square root of 2. So if you remember way back to your pre-algebra days, you're going to remember this weird little rule that says you can't have this radical in the denominator. You guys remember that? Okay? And so in order to get it out of the denominator, you have to multiply by that denominator of rad 2 over rad 2. You guys remember that? No. Oh. Okay. Well, here it is. Okay. So in the numerator, we multiply 5 rad 2, or 5 times rad 2, which is 5 rad 2. And then in the denominator, we multiply rad 2 times rad 2, which is the square root of 4. And what's the square root of 4? 2. So the final answer is 5 rad 2 over 2. And the units here were meters, so I'm just going to put an M.